If we are serious about decarbonization, if we are serious about going into a world which has zero carbon emission, there is no choice but using hydrogen.
While most drivers go for gasoline-fueled vehicles, the ranks of electric car owners are steadily growing. Gasoline and electricity are the two most prevalent power sources for cars. However, the automobile industry is shaken by Toyota's latest invention, a novel car engine powered by hydrogen. This groundbreaking hydrogen engine promises to revolutionize the entire industry. What is a hydrogen engine? What advantages does it offer? And when can you expect to see a Toyota equipped with this innovative hydrogen engine? Join us today as we uncover everything you need to know about Toyota's all-new hydrogen engine. Electric cars have become increasingly popular in recent years, and you might have even experienced the joy of driving one. However, have you ever wondered about the differences between electric and hydrogen vehicles? The answer lies in the way each of these vehicles stores energy. While an electric car relies on a battery that needs to be charged by plugging it into the grid through a charger, a hydrogen car uses a different approach. Instead of a battery, it has a tank that can be filled with hydrogen at a hydrogen station, much like you would fill up your gas tank at a regular gas station. This hydrogen then acts as fuel for the car, powering its engine. The battery in a hydrogen car is referred to as a fuel cell, which converts the hydrogen fuel into electricity to power the car's motor. One of the major differences between a hydrogen car and an electric car is that while the former produces waste, it is not harmful and can even be consumed. Water is the only byproduct of a hydrogen car, making it an environmentally friendly option. The question on many people's minds is whether hydrogen cars will eventually replace electric cars. Before we answer this question, it is important to understand how hydrogen cars work. From a driver's perspective, using a hydrogen car is similar to using a traditional gasoline or diesel car. The driver simply needs to fill the car's tank with hydrogen using a fuel pump at a filling station. The hydrogen then serves as fuel to produce electricity, which powers the car's wheels. However, the technical workings of a hydrogen car are more complex. When hydrogen is put into the car, it goes into a fuel tank, which is fed into the fuel cell. The fuel cell is where electricity generation occurs using a process called normal chemistry. Hydrogen and oxygen in the air are combined inside the fuel cell, which generates electricity. Inside the fuel cell is a liquid with a positively charged anode on one side and a negatively charged cathode on the other. This setup is similar to a battery. Hydrogen atoms split into protons and electrons within the cell, with the former being converted into an exhaust product of pure water, and the latter providing the power for the car's electric motor. Numerous smaller reactions take place within the fuel cell to provide sufficient power for the car's motors. Hydrogen cars also have a battery, which is used to store power for later use. This extra power is useful when accelerating and needing more power from the car. Normally, the fuel cell powers the electric motors directly. One concern with hydrogen cars is the potential for them to be dangerous and catch fire. Hydrogen is highly combustible and can cause significant damage. The Hindenburg disaster is often cited as an example of the dangers of hydrogen, where an airship filled with hydrogen exploded, killing many people. However, gasoline is also highly flammable, and yet gasoline cars are considered overwhelmingly safe. Hydrogen car manufacturers have given special consideration to safety, designing their cars to be safe to drive without the risk of combustion or explosions. The hydrogen that is pumped into the car is pressurized, and the tanks on board are designed to contain this extreme pressure and more, minimizing any potential danger. These tanks are also designed not to leak and are constructed from materials that are extremely strong and durable. In the unlikely event of a leak, the hydrogen engine automatically shuts itself down. The tanks are located outside of the cabin, and any hydrogen that does escape quickly evaporates into the atmosphere with little chance of causing a fire. Hydrogen fuel cells are not only used for cars on the road, but also have applications in space travel. Rockets in space use hydrogen fuel cells, and General Electric produced the fuel cell-based electrical power system for the Gemini and Apollo space capsules during the early 1960s. The space shuttle's electricity is also provided by fuel cells, which also provide drinking water for the crew. The development of hydrogen fuel cells have been crucially supported by NASA, which has funded over 200 research projects, leading to private companies like Toyota and Hyundai being able to take it up. Fuel cells have the advantage that they generate electricity for industrial and individual applications without polluting the environment. Hydrogen fuel cell cars have many advantages over electric cars, particularly in terms of range and refueling times. Electric cars are currently more common, but hydrogen cars offer benefits that make them preferable for some drivers. One of their biggest advantages is their driving range, which can be much greater than that of electric cars. The Tesla Model 3, for instance, has a range of over 200 miles, but starts at $47,000. Larger batteries require longer charging times, even with the fastest charges, which can take over 30 minutes. Hydrogen cars, on the other hand, offer longer driving ranges, such as the Hyundai Nexo, which can last for 414 miles before needing a refill. Refueling takes only a few minutes, making them more suitable for long trips. While hydrogen fuel cell cars have fewer fueling stations available compared to electric cars, they are becoming more common, with new stations opening up every year. As more companies invest in hydrogen fuel cell technology, it is likely that the infrastructure will grow, making them more accessible to the public. Hydrogen cars have many other advantages over electric cars. For instance, hydrogen is abundantly available in nature, making it an almost inexhaustible resource. The production of hydrogen is possible from many sources, such as biomass, natural gas, and water, providing an alternative to the limited reserves of fossil fuels. This not only reduces dependency on non-renewable resources, but also helps reduce greenhouse gas emissions. Another concern regarding electric vehicles is the source of electricity that charges the batteries. Often, this electricity is produced by burning fossil fuels in power plants, leading to carbon emissions and pollution. On the other hand, hydrogen cars produce zero emissions, as the only byproduct is water vapor. This makes them an eco-friendly option for transportation. Hydrogen cars are also quieter than traditional vehicles, reducing noise pollution. They use fuel cells to convert hydrogen into electricity, eliminating the need for internal combustion engines, which require regular maintenance. Hence, these cars have lower maintenance costs, reducing their overall environmental impact. Hydrogen-powered mobility has been recognized by several countries as a potential solution to global climate change problems. While electric cars are being promoted as part of the solution, some countries are also investing in research into hydrogen cars and building the necessary infrastructure to support their growth. However, to use a hydrogen car, access to stations filling up with hydrogen is crucial, and the current infrastructure is not yet comparable to that of traditional ICE cars. Nevertheless, with more investments, the infrastructure will improve over time. The US, China, and South Korea are currently leading the pack in investing in hydrogen infrastructure to support fuel cell cars. One of the hydrogen cars available for exploration is the Hyundai Nexo, an SUV with a 95 kilowatt fuel cell stack and a 40 kilowatt-hour battery pack. Its electric motor is rated at 161 horsepower and 291 pound-feet of torque, allowing it to accelerate from 0 to 80 miles per hour in 8.4 seconds. Another hydrogen car option is the Toyota Mirai, which is based on Lexus running gear, unlike its first edition, built on the Toyota Prius. With an electric motor producing 182 horsepower, the Mirai can go from 0 to 60 miles per hour in 9.1 seconds. Its immediate power delivery makes it feel more responsive when driving around town, and its rear-wheel drive chassis delivers a surprising level of athleticism while maintaining a refined and composed ride. The previous generation model of the Mirai offered 76 miles per gallon of gasoline equivalent and could travel 402 miles on a tank full of hydrogen. The latest estimates for the new Mirai from the EPA are yet to be released. For now, the 2 hydrogen cars are only sold in California, where drivers have easy access to hydrogen filling stations. While the infrastructure for hydrogen cars is still in its early stages, with more investments, we will likely see more growth in the industry and infrastructure improvements over time. Now let's hear what you think of hydrogen fuel cell cars in the comments section below. If you enjoyed watching this video, show your appreciation by giving it a thumbs up and by subscribing for more content. We'll be back to you with another amazing video. Until then, stay tuned.